All right, let's do this. Hello, everyone. Hello, Simon. How are you doing?
I'm fine. How are you, Alejandro?
I'm good. I'm good. Looking forward to our talk. I think it's a pretty interesting topic, kind of developing applications without actually coding a REST API, and also for those who know Vaadin, kind of a rather not that well known feature of the framework, the ability to create or to implement views using TypeScript. Really happy to see you, Simon. We have been talking several times already, doing some kind of collaborations. And for the audience, thank you for joining the talk. Look, Simon's going to present his experience in a bit in more detail, like the actual things or the main things that he has been working on in his career. But I can tell you that he has a vast experience in software development. I think Simon is one of the most experienced software developers that I have ever met. And trust me, working in developer relations at Vaadin, I have met a lot of software developers. And that's the reason why I trust Simon's points of view regarding software development, because you can back it up with that experience, and that's something I really value when you, Simon, present topics or give your opinions on Twitter, for example, where I would encourage everybody to follow Simon on Twitter. Great opinions, and even if you are as experienced or even more experienced, which is hard to beat, then it's a good. I would recommend following Simon there, because you know the value of having opinions from people who have the actual experience in software development. So I'm really happy about that, and I guess you're a very pragmatic man, right? You like to talk about technology from a pragmatic point of view, right? Like things that actually work. But that's my impression, right, Simon?
Yes, that's exactly. I also try to create pragmatic solutions for my customers. I don't like to be too academic or to create too generic solutions, because usually you can't predict the future. So it's most of the time waste of time if you're trying to predict what could happen, because it will never happen like that. And on the other hand, for me, it's very important to choose the right tool for the right job. So that's also why I'm doing this talk today, because it's a solution that may fit a lot of use cases. And as you said, Vaadin has different or two styles how you can create UIs with it. And so that's just one. And the other is also very important or very interesting for, it depends. I will show you or tell you in which situation you could choose which one of these two options.
Yeah, definitely. It's a good thing to be pragmatic, I believe, and very practical. Just like my book, Practical Vaadin, a shameless plug here. Very practical, and I guess you are going to code also in front of us. That's going to be fun. That's always fun, and that's probably I'm going to learn from that. I'm pretty sure. So please ask any questions you have at any moment. Send the questions to the platform or the chat, or just don't hesitate to send your questions. So we're going to try to address the questions, and maybe at the end, if there's time, we can also address some of the questions. And I guess there's the opportunity to join kind of a more interactive session later on Zoom, but we'll see how it works, I guess, after the talk. And yeah, I guess, Simon, you can start with the cool stuff, actually, and good luck.
Thank you. So, welcome to my talk about single-page applications without REST API. Alejandro already introduced me a bit. Here's my timeline. You see, I'm coding since 26 years now. I started on mainframe as a COBOL developer, and later on in the year 2000, I moved to Java. And maybe the question is why I'm talking about Vaadin. Close to 3 years ago, I was asked by a customer to help him in their project. It's an ERP product company in Switzerland. They're building a big ERP systems for many customers, specialized in the German-speaking part. of Europe, so in Switzerland and in Germany. And an ERP system is always built the same way. So it's more or less like create, read, update, and delete data. It has many tables, a lot of business logic, in that case, stored in the database. And they were using Oracle Forms. So maybe some of you may know this technology. It's kind of a way how to write UI code in PLSQL, and then this will generate on runtime a Swing application that you can start with Java Web Start. But the problem, this way of doing applications is no longer modern. They were looking for some way to modernize the UI and to bring it to the web at the end. And because they were using Oracle Forms, they were also using Oracle Apex. Apex is Application Express. It's kind of a low-code or no-code solution where you can do rapid prototyping or rapid application development. That they were looking at the solution that will make it easy for them to create or to migrate the UI. And they also started with a low-code platform, but the problem was that it didn't fit all the requirements. And so they asked me if I can help them in that project. And the first thing that I did, I had a look at the low-code tool that they were planning to use. And the funny thing about this low-code platform was it was generating either a Swing application or a web application. And the web application was created with Vaadin. And so we were talking about the requirements, and we found out that probably Vaadin could be used without the framework, without the low-code platform directly, and we built something that will help them to migrate the application, and we were using Vaadin. Vaadin is, in my experience, a great fit for data-centric business applications because it brings all the needed components that you need to build such applications. So usually you display data in a grid or a tree, and this grid has to provide paging, sorting, and filtering. You have forms to enter the data where you want to validate or convert the data that the user is entering. And so that's exactly what you get when you use Vaadin. You don't have to use any other component framework because the Vaadin component model is very rich and helps you to create such type of applications. And that was also a reason why we choose Vaadin in these days, because Vaadin provided all the necessary component that we needed then. Currently, we are working with Vaadin charts. That's another part of the components of Vaadin where you can doing charts, and we are integrating that to create dashboards and reporting as well in this ERP system. Now, if you already know Vaadin, you may be familiar with this style of programming model. So Vaadin, we will see a bit of the time history, but for those who know Vaadin, Vaadin looks very similar to what you do when you use Swing or any other desktop application programming. So as you can see here, we have a text field, we have a label, we have a button. The button has an event listen when you click on the button, and you add this to certain panel, here in that case, vertical layout that will then integrate the application on the web UI or the components. So if you're a Java developer, Vaadin is very helpful for you because you don't have to learn any other language. But that's not what I want to talk about, because this is just one option from Vaadin. The other one is, as Alejandro already mentioned, is using TypeScript. So why do we have TypeScript in Vaadin now? Let's have a deeper look at, or a closer look to the history. Vaadin is already 20 years old. It started with some HTML, Ajax, and so on. And one important milestone in the history of Vaadin was around 2009 when Vaadin used GWT, Google Web Toolkit. Some older people of you may know it. It was created by Google. In these days, I can't remember just one application of Google. It was Google Wave that used Google Web Toolkit. I don't know any other application that Google used or created with Google Web Toolkit, at least not what's customer facing. Probably they created some internal application with this tool. And this Google Web Toolkit still exists, so it's not gone. You can go to gwt.org, I think, and then you will find the latest version. But the history of Vaadin decided to go another way, and in 2019, and that was exactly the time when I was introduced with my new customer in this custom project to replace the UI, Vaadin introduced Vaadin Flow. So starting from Vaadin 10, Vaadin is different from what you may know from older Vaadin versions that were there before. So what happened then, they decided to recreate the whole Vaadin platform, so the communication mechanism is different, and also the components were recreated. And they were recreated using web components. So web components is a standard how you can extend the tags, the HTML tags that the browser can render. We will see an example later on. And so Vaadin changed the way it works. It also changed the way in how routing in the application works. That was different before. Now you have fully access to routes with Vaadin Flow, with query parameters, location, and so on. And but later on, in more or less 1 year later, there came a second line of how to implement Vaadin UIs. It was called Vaadin Fusion, and that's what what I will talk about. Vaadin Fusion uses TypeScript, so you're not bound to the Java backend model, and it has some benefits. Currently, we are with Vaadin 21. 22 is already in a pre-version available. And as you can see here, Vaadin 14 is the latest long-term support version. We will get another one early next year with all the newest features. So before we start with Vaadin Fusion, I'd like to show you how Vaadin Flow, so the Java-based programming model, works. This is a picture from Vaadin. It shows kind of the architecture. We have a layered model here. On the bottom of the diagram, you can see that we have a backend, and the backend is per default usually written in Java for sure, but uses mostly Spring Boot. You can also have a var deployment to deploy it into an application server, but usually you're using Spring Boot these days. And when you code the user interface, you do it that as well in Java, and you're using components. So you're using the Vaadin components, and the Vaadin components, in fact, exists two times. First, you have a Java representation of the component where you can code the UI as we have seen before in the coding example, but you also have a web component that is available in the browser. So if you add a component like we did before, you will get the web component in the browser. And because we have these web components, we have the possibility to use the web components without Vaadin. So it's also possible to use all the web components that come with Vaadin without Vaadin. So you can use any other framework or no framework at all and use the web components that Vaadin provides. In the Vaadin Flow application, it's a bit special how server and client or client and server is communicating, because they're exchanging the changes in the component model. So if you click a button or enter text, this will be reflected on the server. So you have all the components that are on the client side, also on the server side, and this means you have state on the server. And this is, for some of my customers, this is a problem, because I have other customers besides this ERP product company. They are fine with Vaadin, because, if you're building data-centric back office applications like an ERP system where you can manage customers and products, you usually have a lot of data, but you usually don't have a lot of users. So your data-centric applications mostly don't need to scale horizontally. So to have session state is never an issue with this kind of applications, in fact. Despite if they're using like a platform as we use today, like Kubernetes, and they don't want to have sticky sessions and they want to have horizontal scaling and failover provided by Kubernetes, then the state may be a problem. And So this means we can achieve the statelessness with another architecture. So, and that's what Vaadin Fusion provides. But we use the same programming model in terms of we are using the same components as we would on Java, but we would create this in TypeScript. So how does this look from the architecture side? We have a Java backend. And if you're creating a single-page applications with tools like Angular or React, for example, then you may need a REST API because you need to communicate between the client and the server, and this is usually done with a REST API. The problem if you create such a REST API is you have to implement that. So you're implementing more or less three things. You're implementing the client, the single page application in one of these technologies. You then create the REST API, and on the other hand, on the other side, you have to provide services and business logic and data access to be used by this REST API. So you have three parts in your application. With Vaadin Fusion, you don't have to create a REST API. You just create regular Java interface, Java classes on the backend. We will see that in a minute. And Vaadin will generate the access code on the client side. So this means this communication here between front end and back end will be done with HTTP for sure, but it's more a RPC style communication. So you don't have to care about how this even works because you will get the representation of your endpoint on the back end on the client side. This has some advantages. First of all, you don't have to think about how you create your REST API, what HTTP methods do you want to use. But on the other hand, the biggest advantage, in my opinion, is it's type safe. That means, and it's compile time safe. So if you change something on the back end, then the front end access code will regenerate it. And if, for example, an endpoint has changed, you have a different type or return type, for example, your front-end code will no longer compile. And that's like, if you're a Java developer, you know that from the past. So if you did some Java remoting, for example, or EJB remoting, you had similar programming model. You wrote the server component, and based on that, the stub on the client would be generated by the compiler, for example. Then what we see here on the UI side, if you create the UI with the Fusion, you have an application shell. Like if you have with Angular, for example, you have it with all single-page application frameworks. You need an index HTML file where all the JavaScript code and so on is loaded. And what you usually also need is routing. Vaadin comes with a router component. You will see that in the code example. Where you can map your components directly to some paths, like we see here. You have a route or products with an API. And then you're implementing the components in a TypeScript file. The TypeScript file is using lit. I'll talk about that later on. And there you use the Vaadin components to create the application. And this is, in my opinion, the same as you do when you're using Vaadin Java. Because it's just TypeScript, but it uses the same components. And the main advantage of this style is, first of all, you get the reactive TypeScript framework. I will tell you what this means. So you have kind of a similar programming model to React, I would say. You don't need this REST API, and the application can be fully stateless. That's very important because if it's stateless on the back end, you can scale it horizontally however you like. So you're no longer bound to any server session. That's an important fact. And I think that's also one reason to use Vaadin Fusion. Now I was talking about lit. What is lit? Lit is a framework to create web components. It's also created by Google or from some people from Google. before you may know that there was a Polymer framework. That was the framework that also Vaadin used before, but they now moved to Lit, because Lit is kind of a successor of Polymer. And with Lit, it's very easy to build web components, and you don't need all the boilerplate stuff that you may need if you're creating web components without such a framework. And it's reactive, so you have state, and if the state changes, your UI will be re-rendered, or the component will be re-rendered. And you have a template system, so you integrate the HTML code directly in TypeScript code. That's what we will see here. So this is a simple example. Here we can see that you create a custom element. The custom element is here, or decorate the custom element is there to define the name of the web component. So here we have a hello world view as a web component. It's important to have a dash inside the name, because otherwise you are not a valid web component, because the browser needs this to distinguish between web components and regular HTML tags. And here we are extending from a view. View is a class from Vaadin, but it's just a base class that you can use, but it extends itself from Lit components that have all the necessary functionality to use it as a web component. And then we have some state, here for example the name, and here we have render method, and in this render method we see here in this backticks that this is the template that we build. And what we use here inside are Vaadin components, so also web components. We have attributes with like a label here, or we can have an event listener like this value change. This is introduced by the @ sign here. And in case of a value changed event, we call a method in our hello world view class. So for example, we set the name from the event, and then if someone clicks on the button, we show a notification. So that's how it works. And if you know Vaadin from the server, so Vaadin in the Java flavor, then this is very familiar, because all the components have the same attributes, they have the same events, and you just can transmit your knowledge from a Java Vaadin application to a Vaadin Fusion application. Because I'm mostly a backend developer, I'm a full stack developer, I would call, because I'm doing most of the time also UI code, because I'm working on a lot of business applications, and there it's often better to implement everything from front-end to back-end. It's easier than to split the team in front-end and back-end development. How you do that in your company or in your project depends, in my opinion, based on the applications you are creating. So if you're creating a customer-facing application with fancy stuff, then you may need UX or UI developers that know a lot about UI development. In my case, or in my projects, this is not needed, because we just create applications that display data where user can enter data. And for that, you don't need to know the UI specific stuff, because this is all baked in already, for example, in a framework like Vaadin. And we also create usually like base components that we can use to style and so on, that it looks like applications must look on the customer side. So this is just an example how this could look like. Then I was talking about these endpoints on the server side, and this is the difference from other single-page application development, because here we don't create the REST API, so we don't have a REST controller here, but we have an endpoint. And an endpoint annotation is an annotation from Vaadin. And Vaadin, or endpoint, tells Vaadin to generate from this endpoint, first of all, kind of HTTP endpoint. And on the other hand, it generates the TypeScript code that you need to access this endpoint. And something is very important, because if you're creating a REST API, you have to care about security. With Vaadin, it's the case that all endpoints are secure by default. So if you don't do anything, you can't access the endpoint method. So you have to use these security annotations, for example, permit all, to make the endpoint method public, Or you can use, for example, rows allowed to define this role can access the method, or you can use secured and use expression language in any way to check if the user that is accessing this endpoint method is allowed to do so. So this is also a benefit that you get if you're using this programming model, because it's secured by default and you don't have to care about security on the first side. So the question now is, when do you want to use Flow and when do you want to use Fusion? I would choose Flow if you build a data-centric application with a few users where the server state doesn't matter, and your team consists of primarily full-stack developers. So, for example, I have a university is one of my customers, and they have a development team, and they're building a lot of small applications. So applications, for example, to manage the network, or applications to manage certain aspects of the studies or something like that. And usually you have a team that is creating multiple applications, but it's usually a small team. And there, Vaadin Flow fits very well because you don't have to learn another language. You can stay with Java and you create the single-page application purely with Java. On the other hand, I would use Fusion if I want to avoid server state and if I want to maybe have more interaction on the client side, or to make it easier to access certain things that you can use on the client side. So maybe this could be the case. But mostly the demand of my customers is I don't want server state, so maybe Vaadin Fusion is a better fit. Now I was talking a lot, so how to start with that? Starting with Vaadin is very easy because you just can go to start.vaadin.com, and there is a tool that lets you create your first Vaadin application. And as you can see here, also here on this start.vaadin.com, you have the distinction between Flow and Fusion. For now, we are using Fusion. And so we have kind of a UI editor where we can add some more components, or prepared, not components, but prepared views. For example, here we have something like a master detail where you can edit the data. And there are also possible things you can change theming, you can set security, for example, you can choose from the Vaadin versions that we have here. As you can see here, we have only 21 and 22, the pre-version, because Vaadin 14, that's the long-term support version, does not support Fusion. That's just Flow currently. So what I did, I just created an application like this. And what I can do here, I have a hello world and can enter some name, say hello, and here I get a notification. That's the code from the slides. And this is also the code that I have here in my IntelliJ IDE. And let's first have a look at the project structure. The project structure is based on Maven, or we use Maven by default. There is also the possibility to use Gradle, but not with the start.vaadin.com currently. This only provides Maven, and as you see here, it's creating a Spring Boot application, and Vaadin also brings in a Vaadin Boot Starter project with all the auto configuration that you usually have in creating Spring Boot applications. But that's not very interesting for now. What's more interesting is that you have a regular Maven layout. So you have a source main, Java, resources with the backend code. And on the front-end side, you have a front-end folder. And this front-end folder has, first of all, this shell page. So that's this one. And then you have a TypeScript file where you create a router, for example. And here's kind of an event listener added. I don't explain that further. You can have a look at it. It's more or less stores where you have been the last time. And then we have the routing. And the routing is using Vaadin Router. That's a routing component provided by Vaadin. And what you do here more or less is the same that you do with every router in every single page application framework I know. So you're binding some paths to some component. So here, for example, hello world is on the root path, or we have a master detail path, and this then uses this component. We add some icons and stuff here because what we get when we are doing the starter, we get the full application layout. So this is also a Vaadin component, this application layout. We can here move this around. It's reactive, it's responsive, sorry, and it creates this kind of navigation here in our application, and that's what we add in the router so that we have these icons here. That's not very interesting currently. But what's more interesting is what's happening here in the views. We have this hello world example, and for every component that I create, or for every view that I create in this application, starter creates a folder, and here we have our hello world view. And here, as I said, the view is something that comes from Vaadin, and we have this mobx, and if you go here up in the, if you go up in the hierarchy, we see that we end up here with a lit element at the end. So it's using lit. And we have this decorator with custom element and so on. And now we have this text field enter button. And I was talking about reactive programming, but it's not reactive because it just has a value change event and a click listener. That's not very interesting. What's more interesting is to see how we could react on the change of this field. So what we could do is, instead of displaying a notification, we just could go ahead and add, for example, a paragraph here, and then use our state to display directly inside this p tag. So if we do that and go here and this reloads, then nothing happens. But the question is, why doesn't anything happen? The problem is we have here state in this class, but we didn't tell lit to use it. And so if we want to be able to have this reactive model and to have this paragraph here to react on changes on the Vaadin text field, we can use the state decorator. Now I hope it imports it. Doesn't import it, right? What I'm doing wrong, Alejandro?
Let me see. I don't see what's wrong, actually.
It's right there, I think. Let me
check here something. Oh, well, you're just missing the at sign.
Sorry, yes, thank you. Perfectly. Okay. Yeah, I missed the decorator, or the at sign on the decorator. And now we have state. That means if I go here and type something, you can see now my component is reacting to the changed state. By the way, let's have a look at what is generated on the browser side. Here we see we have this outlet. This comes from the shell. And if you go down here, we see this is now my Hello World web component, in fact. And this Hello World has this text field and this paragraph, and here we have the text that is rendered. Interesting fact about web components is, for example, if we look here at the text field, that it has kind of a shadow DOM. So that means it has an internal representation of this component. And this is not very important usually if you use it, because you just can use it. But what's important about that is if you want to style these components, you may have to access this shadow components here to make the styling. Now we have this state, but if we want to provide or use this hello world view from some other view, for example, or we create this hello world view as a hello world view component, for example, we may access, we may want to access this attribute or this state from outside. And there you can use property. And property is a public state. That means if I go again here and the page reloads usually automatically, so I can have a look here. And now we have an attribute called name. It's not visible here because it doesn't exist, but I can go here and set the name to some code or to some text, and this will be rendered automatically. So lit distinguish between internal and external state. If you were using lit in version 1, because currently we have lit 2, with lit version 1, you had a different decorator. State was not existing. It was called internal property, but now they changed it to state. So that's more or less everything that you need to know about lit. But it's only with that we may not create such a data-centric application. And for that, I brought to you another example. It's the master detail. It's also generated directly by start.vaadin.com. You can do it by yourself. And the interesting thing about this is that this is using, first of all, a grid, and on the other hand here, form. That means if I select something here, I get the data on that side, and I can change this here, and it will save because there is a database started in the background. And this grid here is a Vaadin grid. And this is, as I said, a very fully featured grid component because it, for example, supports out-of-the-box sorting and paging. And paging means, in case of Vaadin grid, it's an infinite scrolling or an infinite scrolling. It scrolls until you're at the end of the data. And but it doesn't provide like next and previous and so on buttons because it's more convenient to just scroll in the grid. And now it's interesting to see how we could use these components. For example, the grid. And what we see here, we just created another element. And here we see the next decorator of lit that we want to use, because we usually want to access kind of an element that we create in our view, in the template. And you can do that with the query decorator. And then you have a selector. For example, here we select the grid with the ID grid, and that's the grid that we see here in the bottom. And here we create, or not here, it's here, that's the grid. And we create the grid, we have some grid sorting columns, and that's it, more or less, from the grid side. Now the question is, where comes the data from? And here we have the same model as we have on the server when we're using Vaadin Flow. Vaadin knows the concept of data providers. A data provider has different implementations. You can have a simple list data provider, for example, but you also can have a data provider that is doing the lazy loading and sorting and filtering, etc. So in our case, this grid data provider that we pass here to the data provider property is a grid data that we are using, and or a method that's called grid data, and this creates the data provider. And here we have the callback, and what we can see here is that in this callback we are executing, or we are calling an endpoint. And here we see what Vaadin is generating from the endpoints. So we have a sample person endpoint, that's this one. Here it's a bit special, it's not secured because we don't have any security in place, so this means we could use anonymous allowed on the class, so this is fully open. And then we have kind of a sample person service that is using a sample repository, so that's just Spring and Spring data. But our methods that we provide here, like list, get, update, delete, and count, are then used to generate the front-end code. So here we have, for example, offset and limit, and we have sort order that we pass here. And with all this information that we get on the list method, we create the call to the service calls the repository, fetches the data from the database, and returns, here in that case, a list of sample persons. Maybe you wonder what this non-null annotation is. That's a Fusion annotation, and this is used to control what the generated TypeScript file looks like. So we use this non-null here and here on the parameters. Now you can argue that you could use not null from the bean validation standard, but this is not possible because not null cannot be applied to the list here or to the type of the list. And that's why we have to use this non-null here. It's just for the generation of the TypeScript data. And now if we go back to our code, we can see here that we have a sample person endpoint with the method list. And this method list at the end calls a sample endpoint with the method list with these parameters. That's how it works. So this class here is generated, and this can be found in the generated folder. So here, down, not here, but here, we see here all the stuff that is generated. This grid sorter stuff here is from a Vaadin helper class that helps to pass the sort order from the UI to the backend. But the rest that's here below IO72, that's from my code, and we have here the sample address endpoints and sample person endpoints that are generated from my endpoints. That's something that we need, so we create the data provider, but the question is also how do we enter the data or how we update the data. So if we go here, we can change the name as I've shown you before, and it updates the data directly. So we're here on this line. Now, if we remind how we did it like this, we have the state. So this is reactive, but this is just one way. So this is no way to have a bidirectional data binding. And for that, Vaadin uses the same mechanism again as on the server. It's called binder. So we have here binder that binds the data to the UI components. So if we go down in and check what's happening when we select an item, that's this method that's called. By the way, this is defined here also on the grid. So if the active item changes, it calls the method item selected. And then it gets the person from the value of the event. And then we check if we have selected items or not. And then we get the person from the backend, because in the meanwhile, the data could have changed in the list or in the backend. And so we have to refresh maybe the person. So we get the data from the backend. And what we then do is we call the method read. And read means that the binder then takes the data from the object that we have here, and it will populate it to the text fields that we have here. So we have here a form layout, and we have some fields, first name, last name, etc. And here we use the binder model and get the attribute that we need. And here this line binds the data then to the value of this input field at the end. And if you hit submit, so we have a button here to save it. Save will again get the binder data, or will check from the binder, if it's new or not, for example. And then it can directly submit the value to an endpoint. So it submits the changed model that is bound to the binder and sends it to update, and update then call the sample person endpoint with the method endpoint, with the method update, and at the end updates the data in the database. And then it clears the form and refreshes the grid. So that's the way it works.
Simon, there is an interesting question from the chat. Alexei is asking the following. What about the WebSockets and asynchronous communication? I think this is related, by the way, to what you're showing right now. So what about WebSockets and asynchronous communication that is not filling in the form and submitting everything? As it is filled, each field is immediately sent to the backend and the front end or view. Is it rebuilt from the backend data? So I guess the question is, what happens? How does it work? It's reloaded the whole thing, or also is it possible to do it asynchronously through WebSockets?
At the end, it is asynchronously, because you have always an XHTML HTTP request, and this is called asynchronously. That's why we also have here this async and await annotations, because we're doing it asynchronously at the end. So that's how it happens here. What happens is to refresh the data, we call refresh grid here. And this refresh grid, maybe we can have a look here. We deselect all items, and if we call clear cache on this data provider at the end, not on the grid, then it will be reloaded. So it reloads the data in the grid. And what it uses there is also this limit and offset to just load the portion of the data that is needed. So the paging happens also if you reload the data.
There's a follow-up as well. So is it without a submit button? I guess the question is if it's possible to do it. I'm not sure. Alex, if you can elaborate on the question, if you mean something like immediate, right? So Vaadin Flow has the kind of set immediate true, where this the value is immediately in the backend, but this is Fusion. So I guess maybe it's something like that. I'm not quite sure if I'm understanding the question correctly. But I would say all this is happening in the client side, right? Okay, so we got a message from him. Can the backend change the cursor position in the form? All right.
No. Because, or not directly, because you're no longer on the server, you're on the client. So you have a really client-server programming model. So the server does not know about the UI. That's different from Vaadin Flow. Vaadin Flow, you think you're sitting on the server and you're doing server-side programming. But at the end, that's also not true. You just execute stuff on the server that then gets through the Vaadin Flow communication to the client. But here we are fully on the client. So it's no difference between Vaadin Fusion, React, or Angular from the way you are creating your application. So that means if you look here at this code, we just have the endpoints, the services, and the repositories. So we don't have any UI related code. So this is fully free of UI code. That's very important.
All right, thanks, Simon.
Back to answer the other question,
part maybe.
Sorry. To answer the other question, what you could do, you could add a value change listener on the field and then save the data if the user changes the field. But the question is if this works, because usually if you have something like that, maybe the data is only valid if you have fill out the whole form, and you may not want to store it in short increments because you always execute an update on the database side, and you may don't want to do that at all. So you may want to have this kind of semantics, because here we have a person, and the person is only complete if we fill out every form element, for example.
Yeah. All right. Yeah. Thanks, Simon, for the answer.
Good. I think we already have 50 minutes close to. Maybe to conclude what I've shown you just some small parts, and there's a lot more to check out. But the reason why Vaadin Fusion was built was really probably because it was already there. The point is, when we look at the history, Vaadin decided to go with web components. And so it wasn't a big step from web components to Vaadin Fusion, because the client-side model was already there. What has been implemented is the endpoint stuff, and so the generated API without needing to code your REST API by yourself. And so Vaadin Fusion is really helpful if you don't want to care about the client-server communication. That said, means also the API that you use with Vaadin Fusion is used for the UI. So you have a dedicated API for the UI with these endpoints, and this depends on your use case. So if you're building kind of a multi-channel application where you have multiple different clients, maybe you have a desktop client, you have a web client, and you may want to have a native iOS and a native Android client, then you may want to create an API with REST, because you have different clients and you want to access maybe the same REST API. Then it makes sense to have REST API. But if the sole purpose for your API is to fulfill the needs of your UI and you're using Vaadin Fusion, you don't need a REST API at all. So that's very helpful and reduces the amount of code that you have to build and to test at the end. So you can concentrate on building the application. That's the same that is true for Vaadin Flow, because there you don't even have to know about client-server programming, you just code on the server. But something that I didn't show you, and it's also an advantage compared to a React or Angular or whatever single-page application framework in combination with Spring Boot, for example, you get a single deployment. So you don't only get a single deployment, you have a single build process. So if you had a closer look at the directory structure here, you see things like package.json, pnpm file, or webpack configuration. And this is generated by Vaadin. So if we have a look at the package.json, here we see all the dependencies from all the components that are used. We have webpack. So if I show you the console, I didn't do that before. There we have it. What do we do? Debug. Here we have it. And if we go up here, we see that we have webpack stuff that's going on here. So we have a webpack development server that is started. And so the programming, again, is not different from if I do that with React, for example, because also there I would use Webpack, for example, to have a development server. And I also have a production build. But the difference is I don't have to configure these. So we have a Vaadin plugin here in our build. So, for example, we have a production build, and this will build the front end. So this will do everything that you would also do with any single page application framework, like minimizing the code and checks and whatever, and build a single deployment unit. But in that case, or in our case, everything comes out as a single deployment artifact, means in that case an executable jar file for Spring Boot. So everything is packed together. And this, for Java developers, is a huge benefit, because you don't have to care about all the build tools and all the frameworks that you usually need to use if you're using JavaScript or TypeScript directly. Yeah, that's it from my side. Are there any questions?
Thank you, Simon. That was very entertaining. I like the coding bit. I have some questions actually, because this come from me actually, because I'm curious. So I'm gonna take advantage of the chance to speak with you, and I guess that's gonna be interesting for the audience as well. So, what's your opinion on why using Fusion instead of, for example, React? Why somebody would prefer that?
Yeah, also my opinion is, but that's just my opinion, huh? But there are other people that have the same opinion. Maybe Adam Bean is one of these guys from the Java community that shares my opinion. Web components are the future, in my opinion, because they are very handy. I was just talking about Vaadin components, but if you go to vaadin.com, you see many third-party components. These are also web components, and you can go to the internet, to Google, and check or search for web components, and you will find many of these web components. And so if you're using web components, or if you want to create web components for your company that other projects in your company then use, you will end up with something like lit element where you create the web components. And then it's a short step just to say, hey, I use lit element or lit for my web application development. So that's the benefit that you get. So you have the same way to create a component, a web component, as you create your application. The only difference is here we extend from view. If you create a plain lit element, you may extend from a lit element superclass, for example.
Yeah, I agree. I'm a Java guy, and I do like, for example, the fact that it's type safe and that I get errors when I'm compiling rather than when I'm running. Sure, we can always automate tests and all that, but if I get the error when I'm compiling, that's a plus for me. And also that leads to code completion, so it completes the things that I have in the backend. If I have an entity like order, or I don't know, to do in these examples, applications that you see frequently, or product or customer or student, whatever, you get code completion there in your IDE because Vaadin generated all these objects for you. So that's really valuable. That makes the experience of coding really, really interesting. Let's see, I had another a question for you here. Can I use Gradle for the build?
Yes, you can use Gradle. The point is it's not directly supported by the start.vaadin.com tools, but there are starters that you can download from vaadin.com/starters, I think. I'm not sure.
Yep. Yeah, I believe so.
And there you can also download Gradle. Maybe the difference is, or the difference in the beginning of Vaadin Flow, Gradle was not directly supported by Vaadin, so it was a third-party plugin that supported that. In the meanwhile, Gradle is also supported by Vaadin, and it will be integrated in further releases and will come to start.vaadin.com, I'm sure. Maybe why I don't use Gradle, because I could also do the demo with Gradle. I think for exactly that use case where you build this kind of application, I would call that self-contained system. It's a term from microservice. It's a type of microservice application where you also have the UI integrated with the application. And there you don't have a complex build. The build is very easy. So you do compile, test, package, and that's it. And for that, you may better go with Maven because Maven is simpler. You don't have to learn, or you can't do fancy stuff with that. Because in my experience, people that are using Gradle are using that because they have a more complex build. They need to do some special stuff during the build, and they don't do the straightforward compile, test, package cycle. And so as long as you don't have this requirement for a complex build, I would better go for Maven. It keeps your build cleaner, because Gradle builds, because you can do what you want, tends to be a bit, how should I say? Maybe they become a bit harder to understand for outstanding or people that don't use Gradle regularly. It's just the difference between Maven and Gradle.
Yeah. Thank you, Simon. I think our time is all gone for this session. I believe we can jump now to some kind of Zoom meeting where we can continue. I have more questions for you if you are up for it. And there's another more question. So I don't know if should we just jump right away there? I guess we should. So thank you everybody for joining this this talk. It was really entertaining to see you, Simon, demonstrating Vaadin Fusion. So let's see if we can solve some of the other questions in the next kind of Zoom room, whatever it's called there, right?